All right, this is part 7 of Robert Temple's A New Science of Heaven read through. So we're getting into the biological side rather than the cosmological side of various issues regarding plasma and such things as that nature. And the last chapter was pretty crazy to read through. With regards to certain um, policies that are in place that kind of restricts me from just reading it plainly. So again, I'll make the disclaimer that this is for educational purposes only. My personal views do not necessarily reflect the views of the author and what is read in the text. Um, I don't, um, I am not giving out any sort of advice of any kind, whether medical, legal, or otherwise. So let's get to the text. Chapter 14, Electric People. I have known many distinguished scientists over several decades and had opportunities to sit around discussing these issues with many of them, often for hours and sometimes for days. The first scientific Nobel laureate I met at aged 18 was Paul Dirac, 1902 to 1984, who won the Nobel Prize for Physics as long ago as 1933. I went to tea with him in his rooms at Cambridge and spent 4 hours with him. He was a great admirer of tea time and made quite a fuss of it, pouring tea and serving dainty little sandwiches, small tarts and cakes. Dirac was very solitary and silent and rarely talked to people. I seem always to have had a way of getting such people to chat. In Dirac's case, I instinctively knew that I must sit in my chair at a 60-degree angle from him so that he could talk without being observed, quote unquote. He had, in fact, put the chair there, and I knew that its angle was the key to having a conversation with him, as he could not talk to people comfortably if they were looking directly at him face on. Yeah, that's highly introverted, I'd say. I can kind of sympathize with that. Dirac shyly confessed to me that he was far more interested in biology than he was in physics. He, but he did, but he said he did not dare that in Cambridge, to tell anybody that in Cambridge. Dirac did not accept physics as it was at that time. He complained that no one would listen to him about quaternions, a number system that he believed essential for understanding quantum mechanics, but which his contemporaries insisted had no practical applications. And he thought physics was in many ways on the wrong track. This had a big impact on me, for there I was in conversation with a living legend of science, and he criticized the very foundations of the of his time, and even preferred to a different scientific discipline from his own because it was more lively. That was an early encouragement to my own skepticism about anything and everything that everybody believes, quote unquote. I have in I have an inclination to think that everybody, quote unquote, is always wrong. We discovered that we had both entered university at the age of 16, and we talked about that and how it teaches one to be a bit isolated from one's contemporaries because they are not really contemporaries chronologically at all, but already well on the way towards becoming ossified and rigid. I have written a long account of that interesting meeting, which perhaps I shall publish one day. Dirac was one of the few scientists who have had the courage to speak of these uncertainties openly, like my hero Percy W. Bridgman did in his books. Bridgman had won his Nobel Prize in 1946. He had been a famous Harvard professor for decades, and he did not give a damn if querulous, and timid colleagues decided to turn on him, savage him, and call him crazy because he was pointing out that not only one emperor, but many wore no clothes. Bridgman was that most honest of persons, someone who is not afraid to admit that he does not know things. He admitted that he did not know what a field, quote unquote, actually was, but he went further and said that no one did. My old friend David Bohm is well known for formulating his alternative interpretation of quantum mechanics, which involves something that he called, quote, the quantum potential, end quote. When I asked him what the quantum potential actually was, he said he did not know, and that no one really knew what any of the potentials in science were. He had come up with the ideas mathematically and hoped one day to find out what it was. But meanwhile, it was just there in the equations and he could describe what it did, but not explain what it was. It is heartening to know that there are some famous physicists who have courage. But if you have courage in life, you will suffer, because the herd will attack you. Most of my scientist friends or good acquaintances, many of them very famous indeed, have been at heart renegades. What does it mean to be a renegade? It means that you use your own brain rather than the herd's brain. I befriended David Bohm in 1982 when he was professor of theoretical physics at Birkbeck College, London. The reason I mentioned David at this point is because I want to quote from my own article. These are words of his that come from the voluminous sound tapes which I made with him over the course of many meetings. Quote, "What is an electric field? We don't know. If we knew, we would know why field and charge are connected in the particular way in which they are. When I was a child, people would say, quote, electricity is very mysterious, end quote. Now we say it's not so mysterious, but still nobody knows what electric force really is. We're used to it, that's all, by giving it a name and getting used to handling it. What is a gravitational potential? What is an electric potential? What is a quantum potential? You see, you would have to explain all of the forces and explain why they act on particles. Now, nobody has done that." End quote. The non-scientist may be astounded to hear this confession from one of the famous physicists of the 20th century. But many of the most brilliant scientists have expressed these and similar sentiments, not only in private, but in many articles and books. One example was my close friend Peter Mitchell of Proticity and the Protic motor, who insisted to me many times that, quote, nobody knows what energy really is, end quote. And the famous physicist Richard Feynman, 1918 to 1988, was honest about our ignorance. He bluntly said, quote, "I think I can safely say that nobody understands quantum mechanics," end quote. And elsewhere he made statements such as these, quote, "Whether the proton decays or not is not known. To prove that it does not decay is very difficult. There are quantum theories of gravity, but there is no way to test them. The best of these theories is not able to include the particles that we do find, and invents a lot of particles we don't find. There remains one especially unsatisfactory feature: the observed masses of the particles m. There is no theory that adequately explains these numbers. We use the numbers in all our theories, but we don't understand them, what they are, or where they come from. End quote. Nobel laureate Ilya Prigozhin strikes again, I suppose, from earlier. What was that, chapter 3? Whose work was discussed in chapter 3, right, it's right there, said, quote, I think we are only at the beginning of science. We are at the beginning of studying the complexity of nature. And the classical universe was a simple, quiet universe. And now we see we only conceive the extraordinary complexity of nature, like, for example, the complexity of the gene expression. We still don't understand completely the structure of the gene. Yet I don't think that once we understand the structure of the gene, we shall see the meaning of man, because the genetic content of a mouse and a man are very similar. Therefore, the non-genetic part of biology is very important, but we know little about it. In addition, I would say there is no fundamental science. Why do we have so many elementary particles? Nobody knows. We still don't know the origin of the universe. The theory of the Big Bang is the most widely accepted theory, but what is the Big Bang? We are at the beginning. I always say that we are at the beginning of a new science, not at the end of science. End quote. So now we have to. So now we come to another remarkable man and great scientist, Albert St. Georgi. Uh, yeah, I think that might be close. I'm sorry, 1893 to 1986, who became a great influence on many pioneers in this field, and with his contemporaries Alfvén, Bostick, Kapitsa, and Cope, one of the greatest heroes of the history of plasma. He was a Hungarian whose surname means Saint George and is pronounced just like Saint Georgie. Okay, well, there we go. We'll just, that makes it a lot easier. He was the second scientific Nobel laureate whom I met when I was 21. He won the Nobel Prize for Physiology and Medicine in 1937 when he was still professor of medical and organic chemistry at the University of Szeged in Hungary. By the time I met him, he was an exile living in America, whither he had fled in 1947 from the communist regime of his native country, and he was working at the marine biology lab of the Woods Hole Institute on the coast of Massachusetts, where I visited him for an afternoon. Things had not gone happily for him in Hungary during the Second World War because of those guys. He had led a resistance movement against them and saved many of those people from being killed, and was lucky not to have been captured to, t that by the Gestapo himself. The Hungarian prime minister sent him to Cairo to negotiate secretly with the Allies, and each man personally issued a warrant for his arrest. St. Georgie was a larger-than-life extrovert, a character with a ravaged face, a good sense of both humor and sarcasm, and someone who was not shy when it came to letting his genius glitter in conversation. So they're kind of the opposite of The Rock. Let's take a sip of this water. Sip. What is important for our story is that it was St. Georgi who laid the true scientific foundations for the electric view of humans. and of all plants and animals also, for that matter. It was not for nothing that his most famous and provocative books are Bioenergetics, 1957, and Bioelectronics, 1968. Hmm. I met with him in the summer of 1966 before the latter book was published. In 1976, he carried his views further and published Electronic Biology and Cancer. He believed that cancer was a condition associated with electrical and electronic malfunctions within the body. The- I mean, the way you word it makes you sound like human beings are cyborgs or something. I guess we'll see in the pursuing chapters, or I mean paragraphs, what he means by that exactly. St. George's Bioenergetics is such an amazing, provocative, challenging, and brilliant book that its full effect has not been felt even today, for it contains insights that have yet to be pursued. It is a BOMB shell, still going off, even though it appeared three-quarters of a century ago. I don't imagine any physicist read it at the time, because it is so heavily technical about biochemistry that few, if any, physicists could have understood most of it. It was published before the discipline now called biophysics came into being. In fact, it was St. George who helped to provide the impetus for the founding of the science of biophysics by injecting discussions of physics into biochemistry to such an extent that biochemists were forced to learn some physics in order to comprehend what he was telling them. Indeed, St. George, in his 1976 book, Biology and Cancer, based a portion of his arguments upon the work done by the famous French physicist Leon Brouillon. Uh, Brouillon is probably not how you pronounce it. Oh boy. 1888 to 1969, thereby forcing any of his colleagues who wished to understand him to study Brouillon's, I'm going to struggle with that one, unique discovery about electronics and the energy levels named Brillion zones, quote unquote, after him. Brillion had been insisting that semiconductors existed inside the body. Hmm. Also, St. George had referred to Percy Bridgman's seminal book, The Physics of High Pressure, 1949, forcing his colleagues to read Bridgman in order to understand one of St. George's most important ideas. For more than 20 years, St. George had been relentlessly pushing physics into biology, and it was becoming impossible to ignore this, so that the discipline of biophysics had to be born to cope with it. He remarked in his 1956 book, Bioenergetics, quote, experimental evidence for the existence of a semiconductor. Semiconductors are necessary for the ordered flow of electricity. Uh, of a semiconductor nature of biological material is not missing. Chloroplasts, the tiny organelles inside plants that carry out the process of photosynthesis, can store light, quote unquote, that is, conserve the energy of absorbed photons, which energy they could again shoot out later in the form of light if heated. That energy can move through protein molecules is an experimental fact. I have no doubts that the coming century will witness a profound revolution, extension of biology, the establishment of a quantum mechanical biochemistry. This book may be but one of the early swallows of this spring. End quote. We will see later that the quantum mechanical qualities of plasma, some of which we have already touched on, are crucial for understanding its role in the evolution of high levels of intelligence. Bioenergetics was indeed an early swallow, and an influential one. It may have gone unread by many people, but they knew it was there, lurking. It was immediately obvious, if one thinks about it, that St. Albert St. Georgi was an outstanding genius who was denied proper recognition in the United States. He discovered vitamin C and won the Nobel Prize, but was he ever offered a professorship in America? No. Was he ever headhunted by one of the Ivy League universities? No. Did the Institute of Advanced Studies in Princeton ever try to recruit him? No. Was he ever awarded any of the usual distinctions? No. Very strange. Instead, he took refuge in an uh, oce- oceanographic institute, which is what Woods Hole is. And he was given a job in a marine biological laboratory. What on earth did St. Georgi have to do with fish? Pretty much nothing. In fact, he was relegated eventually to something called the Institute for Mussel Research. It is true that he had done a lot of research on mussel and was one of the world's experts on the subject, but for him, that was a sideline. What was really going on was that the American scientific establishment was clearly afraid of St. Georgi, wished to exclude him from the mainstream, and tried to prevent him upsetting all their empty apple carts. And the appearance of bioenergetics, throwing a BOMB into the middle of a conventional biological thinking, did nothing to render him less dangerous than the mediocre minds of the establishment figures. With his book Bioelectronics, 1968, St. Georgi became even more of a threat to standard thinking. The first two sentences in his book are, quote, "The greatest stride in biology in our century was its shift to the molecular dimension. The next will be its shift towards the submolecular electronic dimension." End quote. Very ominous. He went on to speak of plasma existing in every molecule of the body, in the body, saying each molecule contains something that, quote, "can be looked upon as an electron gas, pervading the whole molecule," end quote. So the molecule isn't like 99% space or nothing. It's an electron gas, as it were. We'll have to see about this. An electron gas is a negatively charged plasma. Negatively charged because electrons always have a negative charge, being distinct from the ionized positively charged plasmas we have, for the most part, been discussing. Publishing something like this, insisting that was a branch of biology that was electronic, that every cell in the body was electronic, and that every molecule contained plasma was too much for the scientific establishment. Most biologists did not have the faintest idea how electronics worked even in a radio, much less in a molecule. The more St. Georgi published things that required people to stretch their minds, asking biologists to learn a little bit about physics and a little bit about electronics, the more certain it became that he would never be accepted or recognized in America. He could not go back to Hungary because he would probably have been arrested, uh, that and that. He was also not in favor with the American security establishment because he had led an anti-that movement, whereas America in the 1950s and 1960s was being flooded with those people's kind of scientists being brought over by Alan Dulles of the CIA as a part of Operation Paperclip and other such projects. But worst of all for St. Georgi was the fact that H. Mann's personal hypnotist, Ferenc Volgiesi, I don't know if I'm pronouncing that right, who had carried out hypnotic experiments on more than 6,000 those people and gypsies and those things had become Alan Dulus's little darling, given a new identity as Frank, treated as an American, but put in charge of all the American security establishment mind control operations, and he was Hungarian. Rutro Bolgiesi was clearly going to use his influence with Dulles to prevent a distinguished anti-those people Hungarian from gaining any recognition at all in America, lest St. Georgi might spill the beans on Volgiesi being a war criminal and a fanatical that person responsible for the abuse and those things of thousands of those people, and the CIA must have gone into full gear to keep St. George as obscure as possible, hidden away in his little port on the Massachusetts coast, and buried in harmless muscle research, given no attention and having no opportunity to acquire an audience who might ever listen to him. That's kind of a shame. Not kind of, that is a shame. But at least we're learning about him here. St. Georgi was in any case handicapped by terrible personal grief because both his wife and his daughter had died of cancer in 1972. Oh boy. When he dedicated his book, The Living State, with observations on cancer to their memory, he saying in his introduction that cancer, quote, took away most of what was dear to me, end quote. And in his preface, he thanked those few people who had, quote, helped to keep me above water, quote unquote, end quote. That's real tough. Holy shit. Both of them in the same year. That seems a little fishy, but truth is stranger than fiction. A brief but fascinating account of a conversation with St. Georgi had been published in Andrew Marino's autobiography. They met in San Francisco in June of 1980. St. Georgi died in 1986. St. Georgi complained bitterly to Marino that he had never been able to get any federal grants for his research during his years in America, confirming my suspicion that he was blacklisted by the security agencies to make sure he never received any support for anything at all. Despite all of this, Albert St. Georgi laid the groundwork for crucial discoveries and developments in science by helping to create the discipline of biophysics and introducing so many new and exciting notions that are still being explored today. For instance, he is looked upon as the grandfather of biophoton research, quote unquote, a subject I'll be discussing in chapter 15. He describes how ultra-weak quote-unquote photons are emitted by the body, which, when their emission is correctly detected, has enormous implications for the early detection of diseases, especially cancer. He also laid the groundwork for much of Peter Mitchell's work, turning upside down the discipline of bioenergetics and the explanation of how energy is used within the human body, and explaining how energy is transported across membranes and used in cells. But the main point of all this for us here is that the details of what St. Georgi says in his books relate directly to the nature, structure, and workings of intelligent plasma entities. In bioenergetics, St. Georgi refers to the fact that there are several different kinds of ice. This may surprise many people. Surely ice is ice, isn't it? Well, no, not really. St. Georgi found this information briefly referred to in Percy Bridgman's The Physics of High Pressure, 1949. Bridgman was possibly the world's leading investigator of high pressure phenomena, and he refers to, quote, the high pressure modification of ice, quote unquote. With the correct pressure techniques, one could change the form of ice into another. He could he could change ice 1 into ice 3, ice 5, and ice 6, for instance. All of these all these are ices made of pure water, but they are different water ices. Very strange. Research into different ices continues today. In 1998, the number of different kinds of ice increased to 12, as Lobin, Finney, and Kuz published in Nature an account of their discovery of ice 12. But by 2016, the number of ices had grown to 18. Although these different ices are described as, quote, crystalline phases of ice, end quote, they vary a great deal. I don't know why this one letter is highlighted. I don't know how that happened. Very, I must have messed that up. Anyways, their oxygen atoms tend to remain in fixed positions relative to each other, but their hydrogen atoms do not. In addition, in addition to the 18 crystalline ices, there are 3 non-crystalline ices known as amorphous ices. So that makes 21 kinds of ice so far, all of them made solely from water. There is also hair ice, quote unquote, which exists as thin threads spreading between trees, and ice flowers, quote unquote, which are produced by some plants but not others. No one knows why. I guess this is like a depiction of them. Figure 28, a 19th century engraving of ice flowers, quote unquote, as seen through a microscope. Yeah, different shapes and sizes, and like these up here in the top left corner do look like trees. Huh. Does this mean there are 23 kinds of ice? Or are there more? What does it mean to have 21 kinds of ice? Or 23? Or fewer? Or frankly, even only 2? Are the different ices also different kinds of matter? Or is ice just ice, regardless of which of the 18 or 21 or 23 kinds it is? Crucially, it is not only ice that behaves in various ways. In bioenergetics, St. Georgi may have caused the greatest upset to his colleagues of all by discussing the weird nature of water. Here we go. These days, there are many books, many of them New Age titles, discussing different kinds of water at great length. They concern such ideas as water having memory, quote unquote, to explain how homeopathy is possible, where the dilution of a drug in water is so extreme that not one molecule remains, and yet the water appears to retain a potency derived from that drug anyway. And many other mind-boggling ideas. But St. Georgi's thoughts on the strangeness of water in 1957 are so extraordinary that I must quote a bit of what he says. Quote, when considering water structures, we enter a fantastic and fascinating world. Bridgman, in his studies on high pressure, could distinguish between half a score, 10, of different ices, but we need not go to ice to find structures in water. J.D. Bernal and R.H. Fowler showed water to have a quartz-like crystalline quote unquote structure which is different from that of common ice. The situation becomes more complex if we consider water structures built around solid surfaces. The tendency of building structure-ordered layers around surfaces running deep into the fluid phase seems to be a general tendency of liquids. The surface zones of liquids are tens of and hundreds of molecules deep, rather than monomolecular, as commonly assumed. Water around ice behaves not as water but as liquid ice, quote unquote. These layers of ice were found to be several microns deep. The building of lattices means, quote, long-range order, end quote, in which the single molecules collaborate collectively. No attempts have been made yet to apply our knowledge of water structures to living systems. I think, what's his name? Gerald Pollack might have done experiments into that. I'm not sure off the top of my head. I read his book a while ago, a few years ago. I think it's The Fourth State of Water or something, the title. I don't want to go to try to look for his book right now. But anyways, quote, living matter seems to be a system of water and organic matter, which forms a single inseparable unit, a system as the cogwheels do in a watch. Water is not only the mother, it is also the matrix of life on Earth. Biology may have been unsuccessful in understanding the most basic functions because it focused its attention only on the particulate matter, separating it from its two matrices, water and the electromagnetic field. End quote. What is most interesting of all in this for our purposes is that St. George grasped the importance of, quote, structured, ordered layers around surfaces, end quote, within a watery mass. In other words, the concept of a mass of water containing protected or walled cells within itself, which themselves are made entirely of water. These boundary layers within water are analogous to the boundary layers known as sheaths found within plasmas. All plasmoids are enclosed by sheaths. That is how they maintain their identities. St. George had a deep intuition of the extraordinary complex dynamic structures that inform naturally occurring materials, including ice, water, and plasma, but of which science had been ignorant before his discoveries. He had been building complex plasma entities having countless plasmoid regions within them, all protected within their sheaths. Researchers such as Kapitsa, Bostic, and Saitovich have shown that some of the plasmoids contain hot plasmas, some cold plasmas, some dusty plasmas, some non-dusty voids, some containing specific impurities that hinder or accentuate the flows of charged currents precisely in the matter of electronic semiconductors and transistors. Furthermore, there is the mysterious phenomenon called tunneling, quote unquote, to be explained in a moment, that takes place between them. And there are also superconducting and superfluid portions and sections. That water and plasma, which St. George showed to be present throughout human bodies, spontaneously generate structures, adds a whole new dimension to the argument. Hmm. In order to understand the implications of St. George's work in more depth and to see how it works in practice, we will look again at superconductivity and Josephson junctions. That's going to be a tongue twister for me. I'm sorry. Before delving back into the weird and shadowy world of Freeman Cope. Weird indeed. Superconductivity and Josephson junctions in the lab, outer space, and human beings. It often happens in the history of science that a new scientific theory will give rise to new inventions. This is quite natural, but sometimes it happens the other way around. The invention by Brian Josephson of Josephson junctions as a device to control and regulate electric currents in complex machines helped drive the development of machine intelligence and eventually quantum computers. This in turn gave rise to theories that there might be things in nature that have similar functions. We have already touched on the idea that there might be features in complex dusty plasmas in space which have similar capabilities to computers, and that these may help the evolution of intelligence in space. Now we are going to look at features that resemble Josephson junctions in plasma in human bodies. We will do this before we actually explain Josephson junctions. He says junctions a lot, so I might have to abbreviate to J junctions or something. Well, maybe not J, but anyways, the story starts in 1911 with the observation of superconductivity in a lab by the Dutch scientist Heike Kamerling Onnes. Apologies for any mispronunciation. When electricity flows along a wire, it is called electrical conduction. When it flows through something without any resistance at all, an amazing phenomenon that scientists could barely believe when it was first discovered, it is called superconductivity. Superconductivity is entirely counterintuitive. Everything that has traditionally been known about electricity is that it encounters resistance as it flows along. And as everyone who has ever had anything to do with electronics knows, and every electrician who wires your house, the units of resistance are known as ohms, quote unquote, named after the German scientist George Ohm, 1789 to 1894, 1854, excuse me. At first, superconductivity was thought to take place only at extreme low temperatures near absolute zero, temperatures so low that in everyday life we never encounter them because they have to be artificially created by scientists and technicians. But then, as time went on, it was discovered that superconductivity could take place at higher and higher temperatures, and it was discovered that current could that current could flow in this manner through increasing numbers of materials, many of them artificial. As Freeman Cope put it, quote, superconduction is the passage of electron current through without generation of heat, and hence with zero electrical resistance. Such behavior has been observed only in inorganic materials and only at temperatures below approximately 20 degrees Kelvin. On the Kelvin scale, it equals minus 253.15 degrees Celsius. Although although theory predicts that superconduction might occur in organic materials at room temperatures. End quote. Well, I'm just a layman, but it would seem that all these data centers need to be using superconductivity so that they're not generating all this heat that they're generating. Hmm. I'm sure they're trying to work on it if they haven't I haven't looked into how exactly these data centers work. I've only seen things surrounding uh, adjacent to them, not like the actual mechanics of how they work. But it would seem to me that the goal would be to have a reliable superconductivity to keep the whole apparatus from heating up so bad as it does, and using countless gallons of water a day, so much water a day to just keep them cool. So I don't know, maybe the water has to do with that superconductivity or to some degree. I would have to look into it at some other point. Anyways, when current is flowing by superconductivity, it encounters no resistance at all. It can go on forever. It is, in fact, an electric version of a perpetual motion machine. Hmm. If flowing in a coil under suitable circumstances, the current goes round and round by itself with no power source, and it can, in principle, do this for eternity. It needs no recharging. It flows like an endless river. In fact, machines created superconductivity have been made, which all other things being equal, will continue to flow beyond the end of the universe. Well, are these using these machines to power these Data centers? It doesn't seem like it. I'm too ignorant on the matter. I'd have to look into it further. If the universe should actually end, that is, which in my opinion it will not. Hmm. No big crunch of the universe. I don't know if he I don't know if he delves into this anymore. It's just a quick side note. That's his opinion though. The next great breakthrough for our purposes came in 1962 when Cambridge physicist Brian Josephson predicted with mathematical precision how a supercurrent would leap over a thin insulating barrier connecting two superconductors by means of the quantum phenomenon called quantum tunneling, quote unquote. Well, leap doesn't seem like a correct word to use. How do you leap over something that implies like that there's like an opening somewhere in the barrier for something to leap through or leap over? I don't know. I'm just a layman, just a slow boy with no whiteboard. I need a drink of water here. This precision is key. Josephson realized that by modulating the insulating barrier between the two superconductors, the flow of current could be modified. If electricity flows too strongly and too well, it is too powerful for electronic devices and can overwhelm them. And if it cannot flow through and if it cannot flow at all through an insulator, it is obviously of no use whatever. Because of what it became because of what became known as Josephson junctions, it became possible to use superconducting electricity that was not too strong but of semi-strength only, and by varying the semiconductor materials by adding small amounts of this or that substance, what is called doping, quote unquote, the strength of the electric flow could be varied and fine-tuned. These junctions are what make our most advanced modern computers possible, and without semiconductors, the ordinary ones, which had been known for a long time before this and that regulate normal electrical flow very precisely, there would be none of our contemporary electronic devices. There would be no portable computers, no cell phones, no tablets, and hence no internet, and so on. Oof, these Josephson junctions are pretty important then, to modern technology, as it were. Josephson was awarded the Nobel Prize for Physics in 1973 for his discoveries. He is another one of the Nobel laureates whom I have met and talked with about their work. He is a very shy and modest fellow, whose success in science came to him so young that he was rather intimidated by it all, and for a long time seemed to dread all the attention he received. One day I must transcribe the tapes I made of our conversation. Josephson junctions are also fundamental to the development of a quantum computer. Indeed, some scientists go so far as to speak of a quote Josephson quantum computer, end quote. Josephson junctions can now be made at nanoscale with a thickness of only 1/10 of a nanometer. That is pretty small. They are able to act as computer switches so sensitive that they control currents one electron at a time, letting an electron through when desired and blocking an electron when necessary. This level of control has already been perfected, and when quantum computers finally come on stream, it will probably be because of the pioneering work and insight of Brian Josephson. For the radiation detection purposes, vast arrays of tens of thousands of tiny Josephson junctions working in sync are capable of obtaining results unobtainable by any other known means. In dusty complex plasma that has developed emergent properties of self-organization, where superfluidity is made possible superfluidity is made possible by countless layers of sheaths, cells, and crystals. We can expect superconduction and Josephson junctions to form the basis of the energy flows within plasmas. A dusty complex plasma such as the Kordylewski clouds would thus be expected to have more than a trillion Josephson junctions within it, or just to keep adding the zeros as they would in effect become incalculable in number. Intelligent calculations by such conscious plasmas would be so rapid and so massive that a Kordylewski cloud would easily have the capacity to monitor every living creature on Earth in real time and model future events for all of them. Such a cloud would such a cloud could thus foresee with a high degree of probability what would happen in almost any Earth situation, and have models of every conceivable variable's effect on events. From the point of view of a limited human brain, a Kordylewski cloud therefore has the capacity of what to us would be indistinguishable from omniscience. Basically, I think that should let that sink in if I can. And yet, no one, I don't think anyone is talking about these Kordylewski clouds, um, except for like very few people that I know of. Everybody's talking about this, that, or the other, aliens, a holographic universe, this, that, and the other. But no one seems to know about these two clouds that are in the Lagrange points above near us, near the moon. Yet, if this is true, then we should be, at the very least, we should be trying to figure out what these clouds are doing. Anyways, if this complexity is possible in plasmas in space, what about in the human body? We know from St. George's work that the human body contains organic semiconductors. For the achievement of the Josephson effect within our bodies, these can suffice for the necessary barriers, quote unquote, to create the jump, quote unquote. At least he puts in quotations now. The impetus for the jump, quote unquote, can come from something called the proximity effect, quote unquote. When two superconducting currents are near enough to each other, they can influence each other because of their proximity, and this can result in a Josephson effect if there is an organic semiconductor available. To understand the implications of St. George's discovery in more depth, we need to dive back into the weird world of Freeman Cope. I originally discovered his publications in the mid-1970s, as at that time I was constantly in Oxford doing research, though not living or based in Oxford. I would drive down to Oxford from the cottage where I was living in our little Morris 1000, which had an engine like that of a lawnmower, could wind in a cold wind whistling through the soft roof, and a heater so feeble that to avoid freezing in the winter one had to wear a heavy overcoat covering one's legs. Sheesh, that is one jalopy. The irony is that I was studying organic superconductivity, which generates no heat because it encounters no resistance, so it would have been of no use when driving. The journal I had discovered was Physiological Chemistry and Physics, published by the Pacific Publishing Company in Portland, Oregon, which is where they were at the time. They are now in Melville, New York. This exciting journal was packed full of astonishing articles, and they were causing me to look at the physical body in an entirely new light. As I looked into this more deeply, I discovered that William A. Little of Stanford University seems to have been the first person to start this chain of reasoning going. As early as the summer of 1964, he had published a paper in the prestigious Physical Review entitled Possibility of Synthesizing an Organic Superconductor. He concluded that, quote, superconductivity should occur even at temperatures well above room temperature, end quote, using, quote, certain organic polymers, substances made up of large molecules with repeating subunits, which could have considerable biological significance, end quote. After surveying numerous technical issues, he said, quote, this forces upon us the remarkable conclusion that superconductivity can and should occur in structures such as this, even at room temperatures, end quote. These findings tied in with work Cope had been doing since 1963, and he cites in footnotes relevant publications of 1963, 1964, 1970, and 1971, when he published his first major paper making claims of superconductivity in the body. And in 1971 article I cited a moment ago, in this paper, Cope refers to electron tunneling, quote unquote, which is the essence of Josephson junctions. Cope says in his paper, quote, we may predict special characteristics that superconductive biological systems should have, for which pertinent experimental data already exist. First, cells which perform single electron superconductive tunneling might also perform two electron Josephson superconductive tunneling relating to nerve processes. The apparent association of superconduction with growth which is indicated by the evidence of this paper, end quote. The importance of the distinction between single and two electron tunneling is that the latter are of a higher order than when it comes to controlling the flow of currents, and they come into play when Josephson junctions are used to control superconducting currents. A Josephson junction, to put it simply, can act as a switch. The following year, in the same journal, two Hungarian scientists published a paper commenting on Cope's ideas and concluded, quote, the electron tunneling between the mentioned regions of DNA might be responsible for the experimental facts described by Cope. If we accept his hypothesis about superconductive tunneling in biological systems, end quote. In the spring of 1973, Cope published another paper in the same journal carrying his ideas further. In this paper, Cope said, quote, the various species of organisms can detect magnetic fields, excuse me, weak magnetic fields, 0.1 to 5 Gauss. Gauss units are a measurement of the field strength. Indirect evidence suggests that electron tunneling may occur across junctions between superconductive microregions in living systems. Man-made superconductive Josephson junctions have been fabricated with magnetic sensitivity as high as 10 to 11 Gauss. It is suggested that superconductive Josephson junctions in living systems may provide a physical mechanism with more than enough sensitivity to explain the observed responses of organisms to weak magnetic fields. End quote. This might actually tie into mind control to an extent. Because if you're using ELF extremely low fields of ELF pulses to mess with someone's brain, then they're probably using these Josephson junctions to do it. Like obviously, some spook is not going to understand the science of it. He's just there to do what he's been told. As an example, as a hypothetical example, I should say. Because we'll just let that slide for now. Maybe maybe it doesn't really exactly tie into it, but it's magnetic fields, electric current. I mean, all of this does tie into mind control experimentation and other types of experimentation. Anyways, considering what was said about Cope in chapter 13, it is interesting to note that at the end of this paper, Cope states that his work was, quote, supported in part by the Office of Naval Research contract NR 105-1717, end quote. I mean, you have these naval research, the Naval Research Agency here researching these things, and it's also the military that's doing the mind control experimentation, so it all ties in, right? It has to. Cope had obviously persuaded his military security agency bosses that what he was doing deserved funding. A month later, the same journal and his military security agency bosses might have realized that what they could do with such research. So maybe it's very likely that's how he got the funding, because they could use it for their own machinations, obviously. A month later, the same journal received a paper from J.P. Martin extending Cope's ideas to considerations of cancer, and this appeared in the next issue of the journal, entitled Conjectures on Superconductivity in Cancer. The paper by Martin said, quote, on the assumption that biological cell membranes possess superconductive properties and that dead and cancerous cells do not, the mechanism of control for embryonic, normal, and cancerous tissue growth may be explained, end quote. The next spring, in the same journal, Solomon Goldfein, 1914 to 2003, one of the brightest scientists working for the U.S. Army's Engineer Research and Development Labs in Fort Belvoir, Virginia, contributed to the discussion. Perhaps the Army did not wish to be left behind by the Navy. Goldfein's paper was entitled "Some Evidence for High Temperature Superconduction in Collates," quote unquote, and started his paper by saying, quote, when William A. Little examined Fritz Wolfgang London's idea of 1937 that superconductivity might occur in organic macromolecules, he concluded that it was not only possible, but might even occur at room temperature, end quote. By summer, once again in the same journal, Cope published yet another paper which in which he said, quote, superconduction is the passage of electron current without generation of heat, and hence with zero electrical resistance, accompanied by particular kinds of interactions with magnetic fields. Until recently, such behavior had been observed only in certain metals, and only at temperatures below approximately 20 degrees Kelvin. Theorists have predicted, however, that superconduction might occur in organic solids, which theoretically might superconduct even at room temperatures and above. End quote. Cope was also reporting evidence that some functions of nerves are controlled by superconduction, and he proposed that biological sensitivity to weak magnetic fields is comprehensible only in terms of a biological superconductive Josephson junction. Once again, Cope acknowledges the Office of Naval Research in contract number 105-1717. Also in early 1974, Professor uh, Antoni K. Antonowicz of Poland. The Polish don't pronounce the Z's. I don't think the Z is silent. I think, if I remember right. Antoni, we'll just call him Tony. Tony K. Antonowicz of Poland published an article entitled Possible Superconductivity at Room Temperature in Nature. This attracted wider attention and was reported in the New Scientist magazine on the 28th of February 1974, page 525, beside a report on work by Freeman Cope. Antonowicz was reported as using a sandwich of amorphous, which is to say non-crystalline, carbon between aluminium, yeah, there's two I's in there, aluminium films to engineer Josephson junctions, and he, like Cope, discovered that the tunneling involved was modulated by a magnetic field. Cope next delivered a paper to a conference in 1978, the abstract only of which was published in the volume of conference proceedings by the U.S. Department of Energy. He discussed how superconductive Josephson junctions make it possible for organisms to detect not only weak magnetic field lines but also microwaves, and he referred approvingly to the work of Antonowicz. Cope's full paper appears never to have been released for publication. At this point, Cope's involvement in this subject appears to have ended, and in this same year he switched his work to the dipole clouds that have already been discussed. No one else has ever done a survey on these publications, and I thought it necessary to put it all on record, as it was an important episode in the history of science. Since this flurry of exciting papers appeared, the subject has mysteriously gone quiet, quote unquote, in America. Well, we know about that, don't we? That is often a sign that the security agencies are working on it, or if not working on it, then actively suppressing it for some paranoid reason of their own. How dangerous can it be for the public to know about superconductivity taking place within the human body? But several decades of silence is extremely annoying, especially in light of the crucial importance of this almost forgotten subject. What does all of this mean for our discussion in this book? It is fundamental. We are looking at the dynamics of currents of electricity and proticity within our bodies, and an interface between the plasma inside us and our physical bodies. And also, as Cope's work suggests, between our plasma cells and universal electromagnetic fields and perhaps microwaves. In other words, Cope discovered a plasma-based mechanism by which our physical bodies are affected by fields. headset conked out. Let's read. I mean, this sentence is worth restating. In other words, Cope discovered a plasma-based mechanism by which our physical bodies are affected by fields. So of course this is going to go quiet, quote unquote, mysteriously go quiet, because this is obviously has to be implicated in the kinds of experiments that they're doing upon humans and animals and whatever else they're freaking doing. So of course it's going to go quiet, because you wouldn't want like the whole world to figure out what you're doing, much less for other people to figure out how to do it as well. So I mean, there is there is also that, as well as we will see later, quantum biologists have shown that some birds navigate their migrations by means of interaction with the Earth's electromagnetic fields, which have now been shown to cause chemical changes in their brains. Could this interface identified by Cope also work in some more subtle and complex ways in the human brain and account for important features of our own consciousness and behavior? Oh, I think it could. This subject needs to be investigated continuously and relentlessly. Either it has been done in secret, in which case the facts need to be made public, or it has not been done, which would be a major dereliction. In 1989, an unexpected contribution to the subject appeared from Europe. A group of 5 authors prominent in biophoton research published a paper supportive of the idea of superconductivity in organisms. They were Emilio del Guidice, I don't know, Silvia Doglia, Marziale, Milani, Cyril L. Smith, W. Smith rather, and Giuseppe Vitiello. Apologies for mispronunciations of these names. I have had very friendly and productive relations with Smith and Vitiello for some time by email, but missed the brilliant Emilio del Guidice, who was no longer alive by the time I established contact. Their joint paper especially dealt with Josephson junctions in living systems. The 5 authors were preoccupied by what it means for long-range order to occur by correlating behavioral behavior of the elementary components of an organism. The 5 authors say, quote, "A living system can be considered as a set of many microscopic components whose interplay occurs through a network of mutually coupled and sequentially ordered chemical reactions. The macroscopic large-scale ordering could be considered as emerging from the collective behavior of the elementary components. One of the authors, Cyril Smith, and his co-workers have, over many years, found evidence of Josephson-like phenomena are occurring in living systems. The first piece of evidence came in 1975. There is a small superconductive region with dimensions which are very small. A dispersion of such regions could give rise to an AC alternating current Josephson effect. A pair of nearby cells act as a Josephson junction, which gives rise to an intercellular coherence. End quote. In other words, ordered complexity is created in organisms by means of the actions of adjoining cells influencing each other across Josephson junctions. It was impossible for Freeman Cope to enter this discussion because he had already been dead for 7 years. However, a year later in 1990, William A. Little jumped back into the fray, 26 years after his seminal paper in 1964, considered earlier. As an organizer, he took part in an international conference on organic superconductors, which took place 20 the 20th to 24th of May 1990 at South Lake Tahoe, California. This conference was funded by the deceased Freeman Cope's old employers, the Office of Naval Research, under contract N00014-90-J-1384, along with the U.S. Department of Energy. Bill Little, describing himself as principal investigator, quote unquote, wrote the necessary classified final report for the Navy and submitted it on November 30th. This report has now been declassified. It contains a photo of all the participants and a chart identifying them all by numbers. The papers are not included, but abstracts of them are. Little states that the proceedings will be published by Plenum Press, and then he says, quote, "It would be appropriate to mention two items which were brought up by the participants and which might be of interest to funding agencies. The first was a perceived need to develop a better understanding of the process of electrocrystallization. The second was the remark by Professor J. James P. Coleman that the field of organic conductors, organic magnets, and organic superconductors appears to many to have the potential of contributing an enormous amount of to the development of new materials of commercial value in the coming years." End quote. When the proceedings of this conference were published, containing all the papers, none of these remarks were, or the photo appeared. In a brief preface about the history of the subject for the preceding 25 years, Little does not mention a single one of Cope's papers, or indeed any of the papers we have considered here, except for his own of 1964. To me, this gives the appearance of a wish to conceal the earlier history of the subject rather than to reveal and discuss it. In a large volume, Josephson junctions are mentioned only once, and the conference as a whole appears to have taken place in a parallel universe where all that we have considered so far does not exist. And after this conference, the entire subject drops off a cliff, and that is the end of it as far as the public gaze is concerned. Perhaps, quote, the development of new materials of commercial value, end quote, and probably military value as well, obviously, was the reason for this subject going dark, quote unquote, after 1990. In which case, I'm glad to be resurrecting it, since probably no one else would ever have done so. The mechanics of superconduction within physical bodies will certainly also be found in a similar form in plasma bodies in space. There can be no doubt that superconducting regions and Josephson junction switches operate within plasma entities and must occur in their hundreds of millions or billions or probably trillions within the Kordylewski clouds. They will be fundamental to any computing powers of the Kordylewski clouds, and there must be hundreds of thousands of them within each of us in both of our bodies, the physical ones and the plasma ones. In addition to this, superconductivity is, as we saw in Chapter 8, bound to occur within the Birkeland currents that stream through the whole of the universe. There is no reason why such superconductivity within those galactic and intergalactic filament streams cannot travel at speeds known as relativistic, quote unquote, meaning near to the speed of light. As we have also seen, we know that the streams of electrons within the Birkeland currents move forward in a double spiraling fashion in counter-rotating layers. Similar filaments operating in the same or a similar fashion must exist within the Kordylewski clouds and at a micro level within ourselves. These are areas of research that need urgently to be pursued, as we need to know so much more. Indeed. I shall add just one clue as to why the subject may have been suppressed. Everything that I have described above could be exploited in the creation of robots that combine inorganic with organic components. Oh, we got cyborgs now, bro. There are people who write about transhumanism, quote unquote, which deals with this subject. The work Cope, the work of Cope and the others, in fact, has direct relevance to the efforts to build robotic super soldiers, quote unquote, who can enter a battlefield and unalive, unalive, unalive. Isn't that wonderful? Sad trombone. And chapter 15. How are we doing? Guess we can cover chapter 15. How our bodies emit light. All of us emit light, as do all living things, but it is a kind of light that cannot easily be detected. Since particles of light are called photons, a word coined for them in 1916 by the physicist Leonard Thompson Troland, those spontaneously emitted by living tissues have come to be called biophotons, quote unquote. Biophoton emission is not the same as bioluminescence, quote unquote, which is what we see with fireflies, electric fish, and a few other creatures. It is also not the same as chemiluminescence. This is a tongue twister. Chemiluminescence, quote unquote. Light emitted by a chemical reaction, which can also sometimes be seen taking place in living things. All those emissions of light can be seen by the eye, but biophotons cannot. Biophotons are emitted when electrons in the organism get energized or excited, quote unquote. They are therefore useful for detection and diagnosis and as indicators of what is happening in the organism. Biophotons are so faint that they are what is known as ultra weak, quote unquote, emissions of light. What is pop up? Go away. That's if you didn't see it, it was Adobe trying to make me trying to make Adobe the default PDF reader. It does this like every other day. It's annoying. I should try to get it to stop. Anyways, that's neither here nor there. Where was I? If something is ultra weak, then surely you might say it is of no importance, but nothing could be further from the truth. We have good reason to believe that biophotons are fundamental to our existence. And when the emission of biophotons by our bodies goes wrong, it means that we have a serious illness. It is now known, for example, that changes in biophoton emission rates are the earliest possible sign of cancer. So early is there warning that millions of lives could be saved or significantly extended if a mass biophoton detection program were adopted. With such extremely early warnings, incipient tumors could be removed before they become dangerous when were still only a few cells in size. Such tiny incipient tumors can easily be zapped and destroyed by ablations using keyhole surgery. Biophoton detection is not invasive and does not require expensive scanners. It does not bombard the body with radiation. It is an entirely passive process. It need cost very little. Indeed, it can be done by a simple blood test. At the present time, only one machine exists in the world for taking these images. Biophoton research is barely funded and is ignored by all the world's governments except the Dutch. which is strange considering that cancer prevention at an early stage could save such gigantic sums of public and private money in treating cancers. In fact, the world's medical insurance companies would sponsor mass biophoton detection to increase their business profits enormously. For a large-scale biophoton scan of, say, half the body, the person needs only to sit in complete darkness for at least half an hour in order for residual light effects to dissipate. After that, it takes some considerable time to wait for the ultra-weak emissions to register. Here is an image of the head and torso of someone who in total darkness with spontaneously emitted biophotons as the only light source for the image. And here we go. Oh, don't. I thought it was going to freeze up on me for a second. Very ominous. Figure 29. An image of the head and torso of a man sitting in total darkness. The only source of the light forming the image behind being the spontaneously emitted biophotons coming from his own body. For reasons that are not entirely understood, the eyeballs do not emit many photons, and so appear here as dark holes. Image courtesy of Professor Roland van Wyk. Wyk, Week? Very strange. Maybe because some of it, because the eyeballs are receiving, that maybe there's less biophotons being emitted from it. I don't know. Just my guess, I suppose. I'm sure it's probably not that and probably more complex. There is another way to detect biophotons by means of a portable detector with two long empty gloves hanging in the front. A person inserts his or her arms into the gloves, which reach to the elbow, the hands being entirely in the dark some inside the small machine, then have their spontaneously emitted biophotons counted by the machine's twin photo multiplier detectors. Just from counting the biophotons coming from the hands, it is possible to know whether a cancer condition is developing somewhere in the human body. A positive quote unquote finding then suggests that more tests should be carried out to locate it. A negative quote unquote finding suggests that they are probably unnecessary and there is no cancer condition. The main basis for this is that, quote, changes in ultra-weak photon emission occur in the transition from a healthy to a disease state, end quote. And this is the earliest warning sign. But you wouldn't want like a whole bunch of false positives either, if that's even possible with this technology, with this technique of detecting such things. I mean, he said something about it being for not just cancer but other illnesses. So it's like, how do you know which one it is? And that might possibly be why this technology hasn't been pursued further. I don't know. Anyways, biophoton research, despite all its promise, has been shrinking, not expanding. There is little or no funding for it. Public health officials are too dim to see its potential, and it is, quote, outside their comfort zone, end quote. Big Pharma is never going to promote it, and most doctors don't know about it. The heyday of biophoton research was in the 1990s, when many publications on the subject appeared. But at that stage, the detectors mentioned above did not yet exist. So all that was written was based on laboratory research, and the equipment was not yet in existence for public use. The big name researchers in the field at that time have mostly died or retired by now, and have not been replaced. One can go down the list of names prominent then, and one soon discovers that only a few are still alive, and several of those have been inactive because they could not find anyone to fund their work. The combined knowledge of several brilliant scientists from many countries is in danger of being lost to humanity through ignorance and prejudice and greed, I would say. He's being kind of polite, although he kind of mentioned Big Pharma earlier. So, it's not good for business, you could say. And the price of this ignorance and prejudice is that many, many people will die needlessly. It's all part of the plan, allegedly. The leading proponent and researcher of biophoton technology for human health today is probably the Dutch scientist Professor Roland van Wyk, uh, known as Roel, or Roel. I don't know if how you pronounce it. Would it be Roland, Roelen? Anyways, although he is now retired, his son, Dr. Edward van Wyk, leads a group at Leiden University in the Netherlands, to which his father is a leading scientific advisor. They are actively researching biophotons and are apparently the only group in the whole of Europe doing so. Roel did important work earlier with another such group in Japan, headed by Masaki Kobayashi of Tohoku Technical University at Sendai. In 2014, Van Wyk published a mammoth book on biophotons in biology and medicine, which is extraordinarily clear and explanatory. I might have to get that book if I haven't already. It's it's probably really technical though. That would bore most people. It can be eaten. This book might bore people. Crazy. It can easily be read by any medical doctor or person with some basic education in biology. It is described as an interdisciplinary textbook, and the who wants to read a textbook, right? And the hope is that some academics somewhere will actually use it as such. In any case, the book exists, and Van Wyk uh, has been the public and has done the public a great service. However, the number of copies available is now very small, so that the book is not achieving the wide circulation it urgently needs. Biophotons were the first discovered in plants by the brilliant Russian scientist Professor Alexander Gurwitch, 1874 to 1954. Gurvich, well, that's a different spelling. Gurvich is the correct Russian spelling, but he is more widely known as Gurwitch, the spelling used for his German publications. Okay, I'm just going to say Gurvich because that's easier to pronounce. While studying the growth of onion roots in 1923, Gurvich was able to demonstrate the existence of biophotons, though he did not call them by that name. Gurvich's theory was that organisms grew in connection with fields of some kind, which he named morphogenetic fields, quote unquote. He was the first person in history to use the term field in connection with biology in a paper concerning the growth and development of embryos, which he commenced writing in 1911 and published in 1912. But at that stage of his work, he had no proof, only a theory. It was only in 1923 that he was able to demonstrate physical evidence for his theory. He had already concluded that cell division, known in biology terminology as mitosis, quote unquote, in embryos must require not one but two factors. The first was a possibility factor, quote unquote, meaning that the circumstances must become such that cell division was rendered possible. The second was a realization factor, quote unquote, meaning that the cell division having become possible was then somehow triggered. Without this trigger, it simply would not take place. He did not believe that this trigger was chemical. Instead, Gurvich decided that the way the organism as a whole triggered cell division for its embryonic cells to divide and grow must take the form of external, non-chemical signals of some kind. But what could they be, and how could the signals be detected by cells? He decided that each cell membrane must be, quote, an organ perceiving signals for cell divisions, end quote. Gurvich became the first person in the history of biology to use the term receptor, quote unquote. He suspected that the cell membranes must contain receptors, quote unquote, of some kind to detect signals of some kind to cause cell division, which he called mitotic signals, quote unquote. Gurvich then carried out his now famous onion experiment, studying the growing tips of onion roots. A drawing of the experimental setup is to be found on this book's website. The roots had to be even and smooth as possible, and were placed at right angles to each other so that the tip of one root was directed precisely at the zone of the other where cell division would take place. He found that the tip of one onion root, onion rings, I'm kind of hungry. Uh, Pause. Where was I? Onion roots. I was at onion roots. Where is that? Here it is. Which he called the inducer, quote unquote, when directed at the wall of the other onion root, which he called the detector, quote unquote, induced more cell divisions on the side of the detector root that faced the inducer root than it did on the shadow side. This led him to believe that some kind of signals, which he called external impulses, quote unquote, were being sent, affecting the near side much more than the opposite side. It was as if the near side was in the light and the far side was in the shade. Then he had the extraordinary idea of inserting first a glass plate and later a transparent quartz plate between the two roots. He discovered that the glass plate blocked the signals so that no cell division, mitogenetic activity, quote unquote, took place in the detector root, but the quartz plate did not block the signals. This unexpected and bizarre finding ruled out chemical or mechanical signals, since the signals were not blocked by quartz. It quickly became apparent to Gurvich that the mystery could be solved only by postulating that the inducer roots were emitting photons in the ultraviolet range, and that those were the signals in play. As most people know, UV radiation from the sun does not penetrate glass windows, which is why we do not get sunburn indoors, even if we're sitting under a glass roof in the blazing sun. But ultraviolet radiation does penetrate quartz. Gurvich called the ultraviolet signals mitogenetic rays, quote unquote, because they were rays causing cell division, i.e. mitosis. As I mentioned earlier, the word photon, quote unquote, for light particles had only been coined in physics 7 years earlier in 1916, and it was not yet in common use, so the idea of calling his rays biophotons, quote unquote, did not occur to Gurvich. It was the German professor Fritz Albert Popp who introduced the term biophotons, quote unquote, in the 1970s to replace the terminology mitogenetic rays, and quote unquote. A fascinating account of the history of Gurvich's work and discoveries was published in English in 2007 by his grandson, Professor Lev Belousov, jointly with his colleague, Professor Vladimir Voikov, entitled From Mitogenetic Rays to Biophotons. In this account, they explained that Gurvich uh, looked for the evidence in order to support a theory he had formed, and how he found it. Lev and I were in touch and commenced a joint effort to preserve all of Gurvich's writings and place them on the internet. He was extremely enthusiastic about this. Suddenly, he died of a heart attack. What? But his efforts are being continued by his student and protege, Ilya Volodayev, I guess, maybe, with whom I now cooperate in this. We are making good progress in preserving the material that is in Russian. Pause. Where was I? Suddenly died of a heart attack. Yeah, I don't think there's anything involved there. Doesn't seem high profile enough, or a high enough a target. If that were the case, probably not. You know, those agencies aren't God. Anyways, there was tremendous enthusiasm for Gurvich's discoveries, and Gurvich was nominated for the Nobel Prize in the 1920s and on numerous occasions over the years thereafter. But between 1920 and 1939, according to Belousov, more than 700 papers on the subject appeared, as well as books. That's a lot of papers. Gurvich wrote in Russian and in German, and very little of his work has ever been translated but in the 1930s his work became accessible in Europe thanks to the appearance in German of one of his main books, written jointly with his wife and scientific collaborator Lydia Gurvich, Die mitogenetische Strahlung, the mitogenetic rays, published in Berlin in 1932, but by 1939 the Second World War brought about such chaos that communications and academic exchanges were interrupted, especially with Germany. Gurvich was awarded the Stalin Prize in 1941, but after the war his work was forgotten thanks partly to the Cold War between the Soviet Union and the West. That's unfortunate, to say the least. Furthermore, from 1942, Stalin's favorite and wholly dominant pseudo-scientist Trofim Lysenko began to persecute Gurvich, so that Gurvich was not allowed to work in any laboratory and became a political pariah. Gurvich's ideas thus dropped out of sight. My friend Joseph Needham, whose colleague I had the honor to be for some years from the mid 1980s, presciently supported Gurvich's ideas in 1950. But this unfortunately had no significant effect in the widespread ignoring of the subjects subsequent to 1939. Gurevich also discovered that the emission of the ultraviolet photons must be coordinated by the whole organism, which he attributed to its morphogenetic field, in line with his pre-existing theories. He was extraordinarily prescient in this, because the work in physics had not yet been done to explain the mechanics of how such a field might work. It was only after his death that the concept of coherence, quote unquote, in the specialist sense of waves having the same characteristics, such as phase and frequency, within a spatial area, as distinct from its better known usage to describe superposition, quote unquote, in quantum mechanics, emerged in physics as a result of a paper published by Robert Dicke in America in 1954. This coherence only became a concept in biology many years later, which then made it possible to put some flesh on the bones of Gurevich's field theory. It is not granted to us all to live long enough to see our theories justified, but Gurevich did not have this good fortune. But in trying to figure out the mechanics of the process, Gurevich was ahead of his time and became the first person to suggest the existence within organisms of what we now call collective states, quote unquote, and cooperative phenomena, quote unquote, which he which he called the states of mutual alignment and orientation of molecules, end quote, quote unquote. He suggested that this was associated with a redistribution of energy within the organism in an organized fashion at the macroscopic scale, and and that and that chain reactions of signal propagations took place. It was the spatial organization of the whole organism that was important, and it superseded the importance of individual atoms and molecules, demonstrating to him the existence of biological fields. All of these ideas now exist in far more sophisticated form, substantiated by a huge amount of experimental work. But mainstream biology, quote unquote, and mainstream medicine, quote unquote, should show no knowledge or recognition at all of this process. Very weird. With one exception that I know of, a large grant by the Dutch government. Uh, there are no grants or funding anywhere in the Western world for biophoton research, as of this writing anyway. Maybe that has changed since then. This was published, what, 21? So I doubt there's any advancement, but who knows? Drinking a protein drink now. Scientists cannot yet live on air, and until they invent a way to do so, they must either starve or abandon their biophoton work. And biophoton work takes laboratory time and needs assistance, and then the findings need journals willing to publish the results. So difficult was it so difficult was it to find journals willing to publish biophoton findings, even in the heyday of biophoton research, that the small but international biophoton research community had to adopt a different strategy to achieve publication and get around the roadblocks of the unwilling journals. They held numerous international biophoton conferences, gathered up the papers of the speakers, and published them in volumes of conference proceedings. And sometimes anthologies of papers were also published without an underlying conference as a source. The majority of the conferences were held in Germany and Russia, but the papers were published in English. So underfunded were these endeavors that many of the papers translated into English by their non-English speaking authors have poor grammar and spelling, and strange phraseology and usages replicating those of the native languages of the authors. Because there was no money to pay for most of the volumes to be copyrighted, copy edited, and proofread. In quoting from some of these publications, I shall therefore correct their English and thereby clarify their meaning. I shall do this in the rest of this book, simply for the sake of clarity. This defect of language is particularly true of one of the most interesting biophoton books of all, Current Development of Biophysics, published in 1996 by Hangzhou University Press in China. The book is very rare, but it contains some of the most important insights relating to biophotons ever published. It had 3 editors, 2 of whom I know. The third editor was Professor Fritz Albert Popp, whom I was never fortunate enough to meet because of his many years of debilitating illness before his death. The others were Marco Bischoff and Zhang Changlin. Apologies. I give his name in the Chinese form with the surname first. Both of them are absolutely delightful men of warmth, humor, and brilliance of mind. Marco is a great scholar of the history of these subjects who has been tireless in writing and publishing on the subject such fundamental, incisive, and broad surveys that they shall remain classic accounts for ages to come. Leading international biophoton researchers who contributed to that volume were Popp, one of whose most important papers appears in it, Poland's leading researcher, Professor Barbara W. Chwiro. I apologize. Gurvich's grandson Lev Belousov from Russia, Professor Roland Van Wyck, Professor K. Xiu Li of the Chinese Academy of Sciences, and Professor Michael Lipkind of Israel, whose paper was entitled, quote, Application of the Theory of the Biological Field of A. Gurvich of the Problem of Consciousness, end quote. It's a very interesting title. In the attached footnote, I give a list of important books on biophotons in English, many of which are extremely difficult to find, but all of which are of great importance. I have listed them chronologically by the dates of their publication. A list of some important biophoton books in German that have never been translated into English is also included here. These bibliographies are to be found on this book's dedicated website. There are, in addition, numerous volumes not specifically devoted to biophotons, such as those concerning coherence in biological systems, which are nevertheless highly relevant and contain important material relating to biophotons. Some of these will be cited in the closing portion of this book, and where physical coherence, quote unquote, is stressed in a wider context. And of course, there is the book by Van Wyck of 2014 already referred to, as well as a sequel volume by him, which appeared in 2017. It is important to tell people where to find information about this suppressed subject, quote unquote, as it took me a long time to discover and obtain all of these books, and it is not easy to do so. Therefore, I hope I have made it easier for others by listing them. The biophotons themselves are only part of a much larger picture, which took shape largely as a result of studying the biophotons. It was the brilliant Russian scientist Viktor Mikhailovich Ilyushin, who pushed the boundary much further in his writings about bioplasma, quote unquote. This term bioplasma, quote unquote, was coined in 1944 by the Russian scientist V.S. Grishenko, aka Grishenko. Different spellings, one's German, one's Russian, I guess. By 1967, Grishenko and Ilyushin were working together on bioplasma, and they announced then that they envisaged a plasmatic state within living organisms, which, in contrast to inorganic plasma, could be a cold plasma possessing a high degree of order. This was an interesting idea, for the cold plasmas in space, such as the Kordylewski clouds, for instance, are more likely to be intensively ordered and to show emergence, quote unquote, and self-organization, and indeed inorganic life. One would not normally think that the human body could contain a cold plasma, which seems counterintuitive concerning how warm the body is. But Grishenko and Ilyushin worked out that this is possible. And what is more extraordinary, as we will see in a moment, they believed that this cold plasma would chiefly be found in the brain. So, to make it clear, bioplasma is the name they gave to that plasma which they were convinced joined the physical body and helps it to operate, or even coordinated and guided its growth and development. This idea was essentially the same as Aristotle's pneuma. Just to remind the reader, Aristotle believed that ether existed beyond the Earth's atmosphere and was the fifth element, quote unquote, and that pneuma was a somewhat inferior form of ether that actually was found inside physical bodies and helped to animate them. Grishenko and Ilyushin, doubtless without realizing it, have duplicated Aristotle's reasoning and consider plasma to exist in space and bioplasma to exist inside our bodies, hence the bio prefix. And one of the manifestations of the bioplasma is the emission of biophotons. This was a concept where for every organism's plasma body, biophotons would just be one manifestation. Very few Western scientists were ever allowed to meet Ilyushin, since he was considered by the former Soviet Union to be their most brilliant and important expert in the field of parapsychology, with its many military applications, such as remote viewing, quote unquote. Oh boy. His experience first became known to the outside world in the 1970s, and in 1977, a tantalizing brief article by him of only 5.5 pages appeared in English translation in the compendium Future Science entitled Bioplasma, the Fifth State of Matter, quote unquote. In this, he says, quote, a living organism can be described as a biological field, quote unquote, or biofield, quote unquote. We have obtained evidence that a fifth state of matter, bioplasma, exists as a part of each organism's biofield. Bioplasma consists of ions, free electrons, and free protons. It is highly conductive and provides opportunities for the accumulation and transfer of energy within the organism as well as among different organisms. Bioplasma appears to be concentrated in the brain and the spinal cord. At times, it may extend considerable distances from the organism, raising the possibility of telepathic and psychokinetic phenomena. End quote. Hmm. Might be getting warmer here. It was the latter aspects that so interested the military and security services of the Soviet Union. I bet they did. They did. In connection with what they called psychotronics, quote unquote. Psychotronics? Johnny has entered the chat? Satchmo. And they were careful to keep Ilyushin under wraps, whereas the other less important scientists in this field, such as Viktor Adamenko, were allowed to mix with Western investigators. Ilyushin had known the Kurlians, the husband and wife team who were the inventors of Kurlian photography, as they were his neighbors when he was young. As a boy, he had sometimes assisted them in their work. He thus built up a lifetime's background in investigating and experimenting with strange phenomena relating to living organisms of all kinds, including humans, especially psychic humans of the type of the American Ingo Swann, but only those who were within the Soviet bloc, such as the famous Russian psychic Kulagina, Kulagina, butchering this name, Kulagina, let's go with that. The Soviets had some truly spectacular people of this kind, who were the best recorded cases of psychokinesis, which means the ability to move physical objects around by the power of the mind alone, without touching them. It was Ilyushin who provided the scientific theory to explain all of this, and that theory was a highly elaborate one. Let's restart this. And that theory was a highly elaborate one that developed out of ideas of bioplasma. Very little of Ilyushin's work has ever been translated into English, except for secret translations that have never been released by the American security agencies. I have some privately translated writings of his, the earliest of which dates from 1969 and concerns acupuncture. These translations, in very poor English, were commissioned by my friend Marco Bischoff. Bischoff? Bishkov? I don't know. And he kindly let me have copies. Ilyushin's work also related to biophotons, as he wrote in his 1977 article, quote, "Our experiments with light indicates that bioplasma is especially conductive for photons in the ultraviolet range," end quote. That is precisely what biophotons are. Photons in the ultraviolet range. And he adds, quote, "Our group has hypothesized that an organism's bioplasma is an important factor in the emission of light from an organism from causes other than high temperatures," end quote. Ilyushin's concept of a bioplasma body accompanying the physical body, which we might also call a dense matter body, quote unquote, will come back into the discussion in the next chapter. His bioplasma theory follows Gurvich's suggestion that biomolecules in the organism are predominantly present in the excited state, quote unquote. I am again using the term excited state, quote unquote, in a quantum physics sense to mean that a system or an electron has absorbed energy and entered a state of having higher energy than normal. In Ilyushin's account of the energetics of living systems are based on excitation dash de-excitation dynamics. Ilyushin describes bioplasma as a cold, quote unquote, plasma of highly structured collective excitations produced by the polarization of biochemical semiconductors. In other words, the energies in bioplasma bodies are dynamic grids of excitations which interact with fields outside the body. In 1967, at the same time that Grushenko and Ilyushin were announcing their bioplasma hypothesis. The Polish biologist, oh dear, uh, Vladimir's, I think that's the Polish version of Vladimir. Vladimir Sedlak, 1911 to 1993, independently came up with his own bioplasma hypothesis as well. He and Ilyushin later got together and worked on the idea jointly. This was this was facilitated because at the time, Poland was part of the Soviet bloc, so that their mutual cooperation was considered acceptable by the authorities. Ilyushin himself lived in Alma-Ata in Soviet Kazakhstan. Ilyushin also researched biophotons. According to the bioplasma studies of Ilyushin and Sedlak, the plasma particles constituting the bioplasma in the body set up highly structured waves of excitation that, as we have just seen, serve as an energy network. The energies stored in the network form an internal, quote, biological field, end quote. Remarkable as it may seem, this biological field, quote unquote, has a complex broadband wave structure of great stability that stores holograms. Oh dear. In exploring the complexities of plasma in the body and its connections with consciousness and images in the brain, Ilyushin and Sedlak are here leaning on the work of Professor Carl H. Pribram. 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 Let's go with Pribram. Sounds kind of correct. 1919 to 2015, who originated the holonomic brain theory, quote unquote, to explain consciousness using the idea of holographic memory. Most people today are familiar with holograms and are aware that the making of holograms, holography, has something to do with light rays, which, though they may be vague about how it all works, a hologram made by this method is a picture, quote unquote, not of an actual image, but instead of a light wave interference pattern. When the pattern is activated, then the image appears in a three-dimensional mode. The internet is full of explanations of how this is done. However, what few people realize is that holograms can be made without the use of light rays. Carl Pribram explains this at length as long ago as 1971 in his technical book, Languages of the Brain. I'm sure that's a very dry read if he's going to say technical. He believes that holographic processes operated within the human brain and that and were used in the storing and activation of memories in particular. Pribram said, quote, optical systems are not the only ones that can be subjected to the holographic process. Holograms are thus not dependent on the physical presence of waves, quote unquote. This independence of holography from physical wave production is an important consideration in approaching the problem of a neural holographic process, end quote. Clearly, it would take too long to summarize here Pribram's theory of the brain as a hologram, about which many books have been written, not least of by Pribram himself. But it is important to realize that enormous intelligences in the Kordylewski clouds would probably have fantastically advanced holographic capabilities, which would be used not only to store their massive amounts of information, but also to generate images in any form, whether as waveforms, pure data, or optical images that could be seen by the eye, if there are any eyes in the clouds. Technically, none of this poses any problem. The clouds would readily be able to extract 3D images of the kind familiar to us and transmit them to our brains if they wish to do so. Ruh-roh, uh, we could even make a pun and call this cloud holography, quote unquote, and the cloud in this case, of course, is not owned by Apple. Saturn. Another Polish researcher, Adam Gregor Adamski, says that a lot of bioplasma is stored in melanin, which as most people know exists in the skin and protects us from ultraviolet radiation by causing us to get tan or brown. He says, quote, "Melanin is not only a semiconductor, but also a room temperature superconductor. Melanin accumulates in the cells of the nucleus where the genetic material, DNA, is, in order to protect the genetic code from damage from UV rays. These properties of melanin reveal that it has large resources of bioplasma, which the semiconductor properties of proteins and melanin electrons can travel over long distances without losing energy. Bioplasma is understood as a dynamic system in an organic semiconductor. The total energy of the bioplasma consists, therefore, of thermal motion, kinetic energy of particles, floating particles, the field, the electric field, the magnetic field, and solitons." End quote. We can see how, like so much else, these studies draw heavily upon the early pioneering work by Albert St. Georgi, who was the first person to insist that the body contained organic semiconductors, as I have already described, just as the work of Alfvén and his followers has revealed the complex living reality of outer space and the interactions there of plasma and electromagnetism. So his fellow Nobel laureate St. Georgi and his followers have revealed the immensely and astonishingly complex operations of electromagnetism and plasma within the human body and outside it too. Returning briefly to the subject of biophotons, when they are seen being emitted from acupuncture points and meridian lines, they are not a sign of cancer at all, but rather an indication of the normal heightened activity in those key regions of the body. Excuse me. Biophoton scans actually give clear visual images of the mysterious flowing body energy, doubtless a flowing plasma, known as qi, pronounced chi. It could qi or chi, it's interchangeable, I think, maybe, in Chinese acupuncture. These streams inside the body, which have been detected frequently, are known as light piping, quote unquote, more technically described as, quote, channels of light emission, end quote. Such channels form a meridian network. This is one of the most important areas for research since its findings clearly validate the Chinese system of acupuncture points and meridians in the body. The light pipes and the traditional acupuncture meridians are the same. And there you have it going up and down. I don't know about the back. I guess it's, you can only capture so much of it in a picture, I guess, because it looks like it should go down the arms as well if it's going down the legs. Figure 30, biophotons being emitted along the meridians of the backs of the legs. Image courtesy of Professor Roland van Wyk. There we go. Figure 31, biophotons are along meridians of the legs seen in the standing position. Image courtesy of Professor Roland van Wyk. some kind of structure in front of the person. I don't know. Anyways, as we build up a picture of the role of plasma within human bodies and consider the idea that plasma may provide a medium for interaction with universal fields, we see again that ancient wisdom anticipated cutting-edge discoveries in modern science. And that's the end of chapter 15. We ended here.